Hello, welcome to the instructions for Module 6. Module 6 is the very first module of Unit 2. I want to remind us of what it is that we did in Unit 1 so that we're really ready to jump into Unit 2. If you remember, or you could go back and review, the idea of Unit 1 was to get you acclimated to the course and also to give you an understanding of why we use statistics and how we use statistics. Additionally, Unit 1 focused on descriptive statistics. Descriptive means describing. When we looked at concepts like the mean, median, or mode, which are measures of central tendency, we were calculating information about the data by describing it. Now that we have that foundation, we can go a step beyond and really look at the power of statistics by looking at inferential statistics. I know that might be a new word, inferential, but it's based off of the root infer. And what infer means is to draw conclusions. The power of statistics, in particular inferential statistics, is that we can look at a data point or a set of data and decide whether or not the chances are high or low of that type of information occurring based on probability. And we'll get into probability in one of the upcoming chapters. So Module 6 is going to be focusing on Chapter 4 of your OER. This chapter is based on the z-scores, and then we'll build on z-scores with z-distributions. You may have never heard of a z-score before, and that's okay. We're going to take it really slow in this chapter, and each of the assignments that I've created for Module 6 is going to support your understanding of z-scores. You'll complete the usual assignments. Your discussion board and video response will both focus on z-scores. As usual, you will take your quiz for this chapter, and you will also have the opportunity to earn extra credit in this unit by taking the pulse taking survey. Pulse taking survey is basically a survey of how you feel the course is going. I would really appreciate you taking that course, that survey, not just because it gives you an opportunity to voice what's going on in the course, but because I get to hear that information and I can adjust to the needs of the students, and that's really important to me. Okay, let's jump into talking a little bit about z-scores. Remember, this is Chapter 4 of your OER, and I want you to think about information that we could collect. Let's say we just collect one piece of information. Let's use the example of maybe taking an exam in this course. So maybe you take an exam and you score a specific score on your first unit exam. And many times what I've noticed with students is they want to talk to others about how others did on the exam, especially if you're friends with somebody and they'll say, well, how did you do on Unit 1 exam, right? And that's almost the beginning of your introduction to z-scores, because you're saying, how did you do, or how did I do, based on what the rest of the students in the course did. So if you get a score like 100, obviously you know you did relatively well, right? But if everybody got 100, you might start to say, wait a minute, everybody got 100, right? Now, maybe you score a 40 or a 50, which would be considered failing an exam, and you feel pretty badly about that. But then you find out that everybody failed the exam. So when everybody fails the exam, or everybody gets 100% on the exam, we say that there's no variability. Everybody got the same score. But typically, when you're taking a test, students tend to distribute themselves along what we call a standard normal distribution, so that we'll get a mean that typically runs close to 70. That's why we call it a C. And then we'll have students falling higher than a C, we would say above the mean, or lower than a C, below the mean. And you know those things from Unit 1. Now we can say, well, let's standardize those scores and determine how far you scored either above or below the mean in terms of standard deviation. So what z-scores do are they allow us to look at maybe one data point or a sampling mean group of data and say, how does that score differ from the mean based on units of standard deviation or spread in the standard normal distribution. The first time you hear this, you might think, wow, that sounds like another language. But as you start to read, process it more, it will start to make more sense. So it's important you read the chapter. It's important you read over the chapter summary and make sure to review those PowerPoints for this chapter, because the z-scores tend to be more abstract and what really kind of stumps students as they're jumping into inferential statistics. Okay, so you might start to say, why would I want to know that? A score is a score, right? Well, you could look at your score on the exam and compare it to your peers and say, oh, I scored significantly better. That's what z-score allows us to look at, how far you are from the mean, how much higher you scored or how much lower you scored. And then additionally, you might want to compare how you did in a different course. Many times we'll hear people who don't understand statistics say, oh, we can't compare that. It's apples to oranges. Well, the reality is, if we set up z-scores for distributions, we can actually compare how well you did on an exam, let's say for this psychology course, or compare that to how well you did to your peers on maybe an English essay or a science lab that you were doing. So if you find that you scored 2 standard deviations above the mean for your psychology course, you say, oh, I did well, right? And you can look at that by the area of students who typically score in that area under the standard normal distribution. And then if you did 2 standard deviations above the mean on your English essay, now you're starting to really feel great because you're continually scoring in the higher end of the distribution. Okay, so before I finish, I want to tell you that the z-score represents a data point or a mean, if we're calculating means, and it basically represents that score's distance from the entire distribution mean, and the distance is measured in steps that we call standard deviation or the spread. I'm sure many of you have seen distributions before. Just in daily life, we see it used a lot in SAT tests or IQ tests. But we can look at a distribution for any type of information, and then we can calculate or transform that using a z-score or z-score transformation, where we take into consideration the mean or what the average person is doing and how the particular score, how far it is from that average or mean score for the distribution. Okay, I also want to let you know before I finish this video that I'm going to make an entirely new video for our computer lab number 2, because that is going to involve us actually looking at some of the data that we've already manipulated in computer lab assignment number 1 and calculating some z-scores. So we'll get a real good hands-on explanation of what z-scores are and the type of information they can give us. Okay, I will see you back in the next video.